back, more summation formulae. If you're taking summation of the same constant, I goes from 1 to n, then n comes out. This is easy to see, mind you. Suppose I'm looking at some number c, right? And what this means is n times I'm adding c. So suppose n equals 5, okay? N equals 5 and c plus c plus c plus c plus c. I going from 1 to n, I'm taking summation of c, that is c is added to itself 5 times. What does that mean? It is 5c, that's what we call 5c. So summation or sigma, I going from 1 to n of c means repeat c n times. It's saying n times c. On the other hand, if I have sigma I going from 1 to n of c times ai, what does that mean? Well, I don't know what c is or what ai are, but what the summation means, let's write this down. So summation c a sub I means what? CA1 plus CA2 plus CA3 plus so on, right? Suppose you are going until n, then A sub n. Well, that's same as saying get the C out. Common factor A sub 1 plus A sub 2 plus A sub 3 plus dot 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 plus A sub n, right? That is same as C is outside. This is what we call summation A sub I. All right, so that's all we are saying. Summation CAI is C summation AI. If I'm taking two numbers A1 and B1, then A2 and B2, A3 and B3, and then adding them all up together, it's the same as adding A's first together, then B's first together. Likewise, if I'm looking at summation of difference, well, it might be better to add all the A's together first and then subtract all the B's together later. That's all it means. Okay, so I hope this formula makes sense to you. Just use some examples. Say n equals, I don't know, my favorite number 5. What does this mean? Well, when I is 1, I get A1 plus B sub 1. I'm looking at equation 10, all right? I is 1, A1 plus B1 plus I is 2, A2 plus B2 plus I is 3, A3 plus B3. I is 4, A4 plus B4 plus I is 5, A5 plus B sub 5. Got that? Okay. Well, why would I write it this way and not some other way? It's just a rearrangement. Let me get all the A's together. A sub 1 plus A sub 2 plus A sub 3 plus A sub 4 plus A sub 5 plus, let me get the B's together. B sub 1 plus B sub 2 plus B sub 3 plus B sub 4 plus B sub 5. Well, that's what this is, summation AI, and plus is the middle plus. This is summation BI. So likewise, consider example 11, equation 11. Instead of ai plus bi, I have ai minus bi. So I would have minus here, minus here, minus here, minus here, and minus here. So what is it? Let me take look at all the a's. They are all positive. So collect all the a's and all the b's and subtract the sum of b's. That's all this means. That's what this formula means. Okay? Continuing. Here is an example. Evaluate the Riemann sum for fx equals x cubed minus 6x, taking sample points to be right endpoint. You are given the interval 0 to 3 and number of rectangles to be 6. So 0 to 3, you would write fx here and dx here. Well, n equals 6 and my interval is of length 3. So the width of each rectangle is going to be, well, big number minus small number over n. 3 minus 0 over 6. 3 over 6 is half. I hope it's clear. My interval is 3 units long. I want 6 rectangles. So it's going to be 3 over 6. Half is going to be the width of each rectangle. Now the right hand points. Starting from 0. So maybe a picture is in order. So let's draw a picture. I'm going from 0 to 3. That's my number line. Okay. So this is my number line. I'm going from 0 to 3. And I want 6 pieces here. So that gave me 2 pieces. 1, 2, 3 here. 1, 2, 3 here. All right. So this is 3 over 2 over 6. Each piece has length 0.5. I hope it's clear, right? Right? So 3 divided by 6 is 0.5. 3 is the total length. 6 is the number of sub-intervals you have now. So each interval, sub-interval is of length 0.5. So what is this point going to be? Well, this point is going to be 0.5 because that's the width of each. What is this point going to be? 1. What is this point going to be? 1.5. What is this point going to be? 2. Then 2.5. And this guy is 3. Notice I will write the 3 above. Why would I write the 3 above? I want to use right end point. That's the question. They want us to use right end points for each subinterval. For the first subinterval, this is the number I choose. Second, this one, and so on. So 3, the last one would be 3. So keep that picture in mind. So your first point, important point is going to be 0.5, second one 1, third one 1.5, fourth one 2, fifth one 2.5, sixth one 3. All right, you're going to use those points for your Riemann sum. F of xi, those were your chosen numbers, with delta x. Delta x being the width of each rectangle, that is a half. F of, so what are these values? Well, you're using f. That's your function f. So you plug in 0.5 for x and you get this quantity. Plug in 1 for x and you get this quantity, and so on. So these are the values of f, and half is the width, it's common. So I pulled it out as a factor. This is the final answer. That is your Riemann sum. Why is it negative though? Aha, because f is not a positive function. It has some positive parts and a lot of negative parts. So the negative outweighs the positive, and that's why your Riemann sum turned out to be negative. Okay? So with n subintervals, instead of 6, suppose you had n subintervals, then you are looking at total length 3 over n. That's the width of each rectangle. Okay? So you are starting from 0. So the right hand point is going to be 3 over n, 6 over n, 9 over n. In general, 3i over n. Ith rectangle will get me 3i over n. Now you're taking limit and approaching infinity of this expression. Okay, f of 3i over n times 3 over n. Well, this is my function f, that is my width del x. Okay, so simplification. Cube 27 I cubed n cubed minus 6 times 3 18 I over n. Good. Now look, you have 3 here, we have multiplied it in 3 times 27 81, n times n cubed n power 4. Only summation I cube is inside the summation, because n and 27, don't worry about I. Okay, likewise 3 times 18, n times n, 54 over n squared. Summation applies only to I, because I is the running variable here. I is the running variable here. Now use your formula. Summation I cubed is this. That's the formula. Okay, if you remember, summation I cube is this. Okay, that's what we are using now. Likewise, summation I is this formula. All right, once you see, now you are taking limits. Okay, n to the power 4, it will cancel some of the things. N to the power 2, it distributes. They are simply using limit games that we know all about and finding the actual answer. So that is the actual answer, area under the curve. There is a positive part, there is a negative part. Okay, so here is the illustration using thinner and thinner rectangles. With now here are 40 rectangles in all, and you get an approximation close to the actual value, negative 6.75. Here is an approximation. Okay, so negative 7.5 was the actual answer. Here are different values for varying n's they have found out using computer technology, I'm sure. All right, until the next video then, bye.